Hi, this is Purnima Mahalingam, and you're watching video lecture series on power system protection and switchgears. In last video, we are discussed about the basic operating principles of the relays and torque equation, universal torque equations of the relays. In this video, we are going to discuss about the first type of relay or electromagnetic type relay. Come, let's go into the video. Here comes to the electromagnetic relay. What is electromagnetic relay? So electromagnetic relay are those the relay which operates on the principle of electromagnetic attraction types. Everyone know that. It is a type of the magnetic switches which used to use the magnet for creating a magnetic field. This magnetic field is used for opening and closing the switches for performing the mechanical operations. We all know that practically all the relay devices are based on either on one or more of the following types of electromagnetic relay. So first one is magnetic measurements and comparisons and ratio measurements. Magnetic measurements, comparisons, and ratio measurements. These three are the main important. Practically, they related to these three types. And now coming to the working principle. So depending upon the working principles, these can be divided into the following types of electromagnetic relay. So attached armature type. First type is attached armature type, which comes in an attraction type, induction disc type, which comes in as induction disc type, induction cup type relay, balanced beam type relay, and moving coil type relay, and polarized moving ion type relay. These are based on the working principle. The electromagnetic relays are categorized into 6 type. Now coming, let's discuss in detail. Here comes first, here comes the attraction type, attached armature type relay. Here, what happens? Attached armature type relay. Here we can see the relay contact. Here we can see the relay contactor, and here we can see the relay contactors. Once this coil get energized, what happens? Here the coil get energized. This coil get energized. What happens? Because of this, the magnetic field, what happens? It get attached. Because of this, the magnetic field, produced magnetic field starts to attract this. So once it is attracted, what happens? This contactor will close the contactor. Here the trip contactor will closed. Once this coil is energized, what happens? A magnetic field, what happens? It moves the contactor to trip. This is what an armature attraction type. Here we have another type of attract armature type. Attract armature type. Here what happens? The coil. So armature type, hinting armature type. These are the one another type. Once the coil, what happens? Get energized. What happen? It attached. So once it attached, what happens? This get attached, then it gives signal to trip the circuit. It gives the signal, the contactor closes and which trips to the circuits. Another type here with the coil. What happens? This coil get energized, voltage coil. This coil get energized, what happens? This attached. So once it attached, what happens? It closes. When it closes, what happened? Trip to circuit. This is what fixed contact. This is what fixed contact. This is what moving contact. This is a fixed contact. We can see that fixed contact, and this is one moving contact. And after what happens? It moves back by with the help of control spring. Okay. The next type is induction type. So wattmeter type or non-directional type. You can see the wattmeter. You can see the wattmeter picture, and the shaded pole types are non-directional type. We can see the wattmeter type. What happens? This is the act as a relay contactor. You can see the relay contactor. So this clear picture we can see in the next slide. Here we can see in the next slide. See here what happens. Here what happens? The current terminals of the secondary. Once the overcurrent occurs, the current, what happens? With the help of the secondary terminal, the current comes. So once the current comes, what happens? This gets energized. what happens once it gets energized with the help of this is also get energized. So two coils get energized. What happens? The magnetic field produces. So here is a magnetic field produces. What happens with the help of this magnetic field? This disc started the rotate. So what happens? We have a magnetic field from upper side and magnetic field from the lower side. What happens? The disc automatically start rotates. So once the disc automatically start rotating, what happens? The disc is connected with the tripping circuit. So once it starts rotate, what happens? It's trip to the circuits. Here we can see the trip to the one starts rotated. It moves. What happens? When it moves, it trip to the circuits. But here we can see that when it moves, it trip the circuits. Here we have a current coil. Once the coils gets energized, what happened? We are produced. So flux phi1 is produced and flux phi2 is produced. So both the flux starts moving the aluminum disc. It's like an wattmeter type. And coming to shaded pole type, what happens here at a shaded pole type? We have an actual coil. If this get energized, what happens? The flux here, what the pole, what happens? You can see the difference. What happens? The flux splitted. So shaded rings, we can see the shaded rings. So in particular side, the flux gets thickened. What happens? It starts moves the disc. You can see here moving contactors, spindle disc, shaded rings, and this is a fixed contactor. Once it starts moves, what happens? It gets attacked. Uh, Here coming to the induction cup type, because the induction cup type, what happens when the coil gets energized? What happens? This because of this, the flux produces. Because the flux produces, what happens? This starts rotate. This starts rotates. So once start rotates, what happened? This rotor get attached to the circuit, trip to circuit. The contactor closes and trip to the circuits. Here we have another type. Once this coil gets energized, flux produces. Because of the produced flux, this it starts rotates. So now coming to the balanced beam type, we have two types of coil. One is restraining coil, one is operating coil. Already we are discussed in the previous classes. Operating coil is to close this contactor. Restraining coil is used not to close the contactor, which is open the contactor. When starting the restraining coil gets energized, when the current overcurrent occurs, what happens? The operating coil get energized. What happens when the operating coil gets energized? What happens? Balanced beam, this get attracted here. Once it get attached here, what happens? This trip contactor gives signal to relay. A trip to the contactor gives signal to the relay. So it's a balanced beams type. Now coming to the moving coil type, we know that the moving contactor and there's a fixed contactor. Here the coil gets moves when it trip to circuits, etc. So when the supply is given. And here we can see the moving contactor type. This contactor get moves and trip to the circuit. This is the picture diagram. This is a damper. This is a spring. This is the coil, and we can see the coil and pumper. Once the moving coil type. Okay. And finally, we are summarizing here electromagnetic relays. What empathy? We are going for empathy? So fault, overload as equipment damage and safety concerns. So here we have seen what is relay, what is automatic fault isolations. We have seen overcurrent, overvoltage, attraction, induction, and pros and cons, cons, and it used for transformer, motor protection, distribution protection. We have a digital relay, how fast it is works. And the ideate part, we have an electromagnetisms and attract the armature and contacts and trip signals, etc. So I hope you enjoyed this videos today. We'll meet in next video. Thank you so much.